Alright, so some of today is a little bit of a review. Do you remember when we learned about our properties a couple weeks ago? Our commutative property, associative property, identity property, and distributive property. So we're just focusing on our distributive property for right now. Do you remember what it means to actually distribute? If you're distributing a number, what does it mean you're doing with that number? So you have a problem that looks like this, correct? If I'm distributing that 7 to that m, what does it mean? Passing it out. Distributing means, am I adding, subtracting, multiplying, dividing? It means I'm multiplying, so it means 7 times m. You keep that plus sign. And then you distribute the 7 to the 5 as well, meaning 7 times 5. Do you remember that? So then you have the problem 7 times m plus 7 times 5. Once you multiply, you get 7 times m plus 35. Okay. 7m plus 35 is an equivalent expression to 7 times m plus 5. They mean the same thing. So that means that they are equivalent expressions. Okay. What is different between this problem and this problem? Yeah, this one has a subtraction sign. The way that they worked it out is a little bit more complicated. I'm going to show you the way that I prefer to work it out, and I think it's the way that you might prefer too, and I think it's a way that maybe might help you not to make as many mistakes. So I'm going to rewrite it over here. Whoops. 3 times n minus 8. Can y'all see that? Alright, so if I'm distributing, that means I'm distributing it to that n. So what does that mean? Multiplying, so 3 times n. In that very first problem, I kept that addition sign, correct? Yes. I want to do the same thing, and I'm going to keep that subtraction sign. And then I'm going to distribute the 3 to the 8. So that means 3 times 8, which gives me what? 24. Did I get the same answer as they got over here? Yes. It just took a couple fewer steps, correct? You can do it how they did. They changed the n minus 8 to n plus negative 8, which is the same. Remember, subtraction is the same as adding a negative. So that's okay. And we're actually going to do that in a couple of our problems later on. But when you're just distributing, I think it's easier to just keep whatever sign they give you and then simplify at the end. Okay? But you can do whichever you choose. Alright, so number 1. I got 3 times d plus 4. So what does that mean? What am I distributing? Charlie? Good. It becomes 3d plus 3 times 4, which is actually what? 12. So it becomes 3d plus 12. Alright, number 2, I've got my parentheses first and my 4 last. Does it change anything?
No.
No. Yeah, you're still keeping it the same. I'm going to multiply my 4 times the w first. So that means I have 4 times w. I'm going to keep my subtraction sign. And then I'm going to multiply 4 times 5. So what do I get? 4w minus what? 20. If you multiply the 4 times the 5 first, does it change anything?
Yes.
Somewhat. Because you have to be able to realize that that's actually a minus 5. So it would be 4 times negative 5, which would be negative 20. See how we got minus 20 here? So it would be 4 times negative 5, which will give you negative 20, plus 4 times w. Okay. So that's why I say stick to multiplying by that first number first. The first number in the parentheses. And then you might not forget about that negative. Does that make sense? Or does that just confuse you more? Because it says minus 5, that's actually a plus negative 5. Remember that? Because subtraction is the same as adding a negative. So if you're multiplying the 4 times the 5 first, you have to remember that that's actually a negative 5, not a positive 5. Okay. Alright, number 3. Negative 2 times c plus 7. So that means I'm distributing that negative 2, so I have negative 2 times c plus what? Negative 2 times 7, which gives me negative 2c plus negative 14. Is that in the simplest form possible? No, why not? Yeah, this adding a negative, remember that we can change that to a subtraction. So we want to change that to negative 2c minus 14, and that's my final answer. So anytime you have minus, or plus a negative or minus a negative, you want to go ahead and change that to plus or minus, whichever one it changes to. Okay? Number 4, 9 times b plus 4. What is that going to give me? Somebody want to take a stab at it? Caleb?
9b plus 9 times 4.
Okay. And then how do I simplify that?
9b plus 36.
Good. 9b plus 36. Number 5. I've got my 8 on the opposite side again. I'm still just distributing it. So I have 8p minus what? 8 times 10. Minus 80. And number 6, negative 11g minus 6. So I'm going to distribute that negative 11. So that means I have negative 11g. I'm going to keep that subtraction sign. And then I'm distributing the negative 11 to 6. So that means negative 11 times 6, right?
Two signs the same add subtract.
Yeah, so first, what is a negative 11 times 6?
Negative 66. I know, positive 62. Because two signs.
Well, negative 11 times 6 is negative 66. And now, what you're saying, I have two negatives right next to each other. So my final answer has to be negative 11g plus 66. Any questions on that distributive property? We good? Alright, go ahead and flip it over. Now we've got a few vocab words, which some of them we have already heard. Whether we remember them or not sure. So the first vocab word I have is a term. I've got a coefficient, a constant, and then I have like terms. We're going to be looking at algebraic expressions. Does somebody remember what an algebraic expression is? So just an expression, yeah, it's an expression that has letters in it. So just a regular expression is like 2 minus 5, right? An algebraic expression would be 2x minus 5. It has numbers and letters, okay? So if we look at these examples of algebraic expressions that we have right here, my terms, those are every little piece of that expression. So my terms are 6a, negative b, 2a, and negative 7. Okay, so your terms are just every little piece, every number or variable that is separated by a plus or minus sign. Okay, Your coefficient, do you remember what that is?
No. The numerical part of the term
That also contains a variable. So that means it's the number in front of a variable. Thank you, Caleb. So my coefficients would be 6, negative 1, because remember negative b is actually a negative 1b. Remember that from yesterday? And then it would be 2. So your coefficients are every number that is tied to a variable. Okay. And then we have a constant, which is just a number. So it's not a number in a variable, it's just a simple number. So in this case, it would be negative 7. Okay. And then our like terms are terms that contain the same exact variable. So because 6a and 2a both have an a in them, they are like terms because they both have a's. Okay. So go back to our coefficient. When you look at this problem, do you really, is it hard to tell that that is a negative 1 because it's minus b? Kind of. If you're just looking at your b and you're not paying attention to the sign in front of it, you might just think that that's a 1 right there, right? I want you to take all of your subtraction symbols and we're going to change it to plus a negative. So remember, subtracting is the same as adding a negative. So anytime we have a problem that is something minus something, we're going to change it to plus negative so that we get those coefficients and those terms correct. Okay. So looking at this first example that they've already done, my original problem is 4m minus 5m plus n minus 7. Because I have a minus 5m and a minus 7, I want to rewrite it as adding a negative. Okay. So now I've got 4m plus negative 5m plus n plus negative 7. Okay. Remember that anytime you see just one variable together, it's actually an understood 1 in front of it. Okay. So now when you're looking at your terms and coefficients and constants and all that, it's easier to tell that that's a negative 5n. So my coefficient would actually be negative 5, not just a 5. Yes?
On the part where it has all the arrows pointing to like the 6a minus b, since the 2a and the 6a are like terms, would you do 6a minus 2a or 6a plus 2a?
You would take the plus. You would take the sign that's before the next one. So if you were looking at these two, it obviously would be minus. But you're going to take the signs that are in front of each number. So because the plus is in front of the 2a, you would add the 6a and the 2a. Okay. All right, looking back right here. If I'm looking at my terms, they said that I've got 4m, I've got negative 5, and I've got 1n. Did they make a mistake? What about negative 7? Is it a term as well? Yeah. Everything is a term, right? So they left off their negative 7. So add that in there. Your terms should be 4m, negative 5m, 1n, and negative 7. Your like terms are 4m and negative 5m because they both share an m. And then your coefficients are 4, negative 5, and 1. Don't forget about the 1. And then your constant is just that negative 7. Okay. All right, so let's do some. First off, I'm going to abbreviate so we're not writing all these long words. So for terms, I'm just going to put T. For like terms, I'm going to put LT. Coefficients, I'm just going to put COEF. And then constants, I'm just going to put CON. Okay. All right, so for number 1, what are my terms? My terms are everything. Charlie.
2, 6a,
Good. 2, 6a, and 4a. Do I have any like terms? Yeah. What are they? 6a and 4a. Because they both share an a. What about my coefficients? Hudson. Good. Those numbers that are tied to those variables. So 6 and 4. And then what about constants? Charlie. 2. It's just that number. Good on that so far? Okay, looking at number 2. What are my terms there? Charlie?
1M, 4M, 2M, 5M.
Good. It's just all of those terms, all of those numbers. Do I have any like terms? Yeah. I've got 1M, 4M, and 2M. Because they all share an M. What about my coefficients? 1, 4, and 2. You cannot forget about that 1 that's in front of that M. Remember that that's an understood 1 right there. So that's why that 1 is a coefficient as well. Okay. And then a constant. What's my constants? 5. It's just that number by itself. Alright, number 3. Do you see a subtraction sign in there somewhere? Yes. So remember, this is when we need to change it. We need to rewrite it to adding a negative. So I'm going to rewrite this as 3C plus 4D, bless you, plus negative C plus 2. So now my terms should be 3C, 4D, negative C, and 2. What about my like terms? Caleb?
3C and negative 1C.
Good. 3C and negative 1C. If I had another term in there that was 2D, does that mean I would have 2 different sets of like terms? Yeah, so you can have multiple like terms. Just whenever you're listing them, make sure that you put your like terms together. So 3C, 4C, 2D, 4D. So just put your C's together, your D's together. Okay. What about my coefficients? Yeah, good. 3, 4, and the tricky one, negative 1. Because that negative C is a negative 1C. And then my constants. 2. Good on that? Okay. Flip over. Now we are simplifying algebraic expressions. So just like we simplified on our test yesterday, simplifying means that you're doing everything you can to get it, basically to get it into a shorter problem. Okay. So if we're looking at example number 1, I've got 6x minus 5 minus x plus 7. Remember, anytime I see a minus something, I want to go ahead and rewrite it as adding a negative. Okay. So when we rewrite that, that means I have 6x plus negative 5 plus negative x plus 7. Okay. Now I need to look at my like terms. What are my like terms?
6x.
Yeah. My 6x and my negative 1x, right? They both share an x, so that means that they are like terms. They went ahead and rewrote them using that community property. They reordered it so their like terms were next to each other. I don't really care if you do that. I normally just I underline some of them and then say my coefficients, my constants, I would just squiggle or box them and circle them. If you want to rewrite them so that they're next to each other, that's fine. I don't care. Just as long as you can look at that problem and see which ones are your like terms. Okay. So now that I've got my 6x and my negative 1x, you're just adding those numbers that are with them, those coefficients. So what is 6 plus negative 1? 5, so that leaves me with 5x. And then my constants, my numbers, negative 5 plus 7 gives me positive 2. So 5x plus 2 is my simplified expression. Okay. Questions on that? Caleb?
Why can't it end up being 7x?
7x? Because they are not like terms. One of them has an x and one does not have an x. When you see that 5x, that means 5 times some number. So if you knew what x was, if x was 2, you would have to do 5 times 2 first, which would give you 10, and then 10 plus 2, which would give you 12, which would not be the same as saying 7x. Does that make sense? So you can only add things together if they are like terms. So if they have the same variables, you can add them together. You can add those numbers together. But if they are not the same, you cannot do anything with them. Okay? I'm glad you asked that. Good question. Alright, and then this second example is showing you how to work a problem when you have, what is this called right here? The distributive property. So anytime that you have an expression with the distributive property inside of it, you got to do that first. Okay? So we can look back at that. I just want to go ahead and skip down and do some by ourselves, because I feel like it's easier to learn when you're actually doing it yourself. Alright, so number 5, I've got negative 15e plus 7 minus 5e minus 9. What do I want to do first with those minus symbols? Caleb.
Like, do like 7 plus negative.
Right, we want to change it to adding that negative. So negative 15e plus 7 plus negative 5e plus negative 9. Now, looking at that problem, can I identify my like terms? Yes. What is one set of like terms? Charlie. Good. So I've got negative 15e and negative 5e. Can I combine those? Because they're like terms, I can. So what's negative 15 plus negative 5? Negative 20. So that means I have negative 20e. And then what about my constants? Can I combine those? Yeah. So I've got positive 7 plus negative 9. So what does that give me? But negative 2. So is it plus negative 2? What would it?
That's all you do.
Can I simplify that a little bit further though?
Yes, you can.
Yeah.
Negative 20e minus 2.
Good. I want to go ahead and make sure that I'm simplifying that plus a negative. I want to change that to just a minus. So negative 20e minus 2. Okay. Questions on that? Okay. Number 6. What do you see right here? Distributive property. Before I take care of that, I see a negative right here though, right? So let's go ahead and rewrite it. So I've got negative 8 times r plus 6. And then what's that going to change to? Plus negative r, right? Can y'all see that okay, or is it too small? Good. Alright, so now that I've rewritten that subtraction, now I can take care of that distributive property. So I'm going to distribute the negative 8 to the r, which leaves me with what? Negative 8 times r. And then I've also got to distribute it to the 6, correct? So that means I have negative 8r plus what? Plus negative 40. And then can I just copy down the rest of that problem? Oh, sorry. Thank you. Not 8 times 5. So now can I copy the rest of that problem down? Yeah. So I'm just going to tag on plus negative r plus 1. Alright. Now how do I simplify that? Dylan. Yeah, so what are my like terms? Negative 8r and negative r. So when I add those two together, what does it give me? Negative 9r. And then what other numbers can I add together? Charlie. Yep, negative 48 and 1. So what is negative 48 plus 1? Negative 47. And then I want to go back, and I want to change that, adding a negative to subtraction. So negative 9r minus 47. That's my simplified expression. Questions? Are we good? Some of us look confused. Do I need to do number 7? Yeah. Okay. Alright. Negative 12c plus 3 minus 9 times 11 minus c. So when you see those parentheses, what does that mean? Means distributive property. But that minus 9 is kind of tricky there. Because am I distributing a positive 9 or a negative 9? Actually a negative 9, so that's why I want to go ahead and rewrite it to make sure that we don't make the mistake and distribute a positive 9 instead of a negative 9, okay? So this is going to be negative 12c plus 3 plus negative 9 times 11 minus c. Okay. So before I can combine any like terms, I've got to evaluate this distributive property right here. Okay. So I'm going to actually make a little note of that and circle it. So and you might want to do this too, so that when you're looking at your notes, you can figure out how did I get from one place to another. Oh, sorry. So that's the very first thing you need to do, is do that distributive property. So I'm just going to go ahead and copy down my negative 12c plus 3, because I know that I'm not doing anything with those two numbers right now. When I distribute that negative 9, I'm distributing it to the 11 first. So that means negative 9 times 11, correct? So what does that give me? Negative 99. And then I'm going to keep that subtraction sign. And then I'm also distributing that negative 9 to the c. So that means I have what? Negative 9c. Okay. Can I do something with those two negatives?
Yes.
Yeah. Those two can turn to a plus. I need some color coding here. So now I have the problem. Negative 12c plus 3 plus negative 99 plus 9c. Can I figure out what my like terms are now? Yeah, now I can do that. So what is one set of like terms? Dylan. Yeah, negative 12c and 9c. So what is negative 12c plus 9c? Close. Close. Is 12 larger or 9 larger? Negative 3c. Negative 12 plus 9, they're different signs. So that means I'm subtracting, and then 12 is larger, so that's why it's a negative. Okay. And then what else can I combine? The 3 and the negative 99. So what is 3 plus negative 99? Negative 96. So I've got negative 3c plus negative 96, which is actually negative 3c minus 96. Are we good? I want you to do the rest of the problems for homework. Not these back 2 pages. Not this. Not this. The 3 pages that I did some of the problems with you, you're going to finish them. So on the first page, you're finishing 7 through 15. Second page, you're just doing those last 3 problems. And then that third page, you're doing, how many is that? 7 problems. Okay? Do not touch these 2 pages for homework, or you literally will be up until midnight. These are not homework. Got it? Okay. So hopefully you don't have too much, because I know we're all busy.